Hello, hello, Course 3 students. Hey, welcome to our last lesson here in Chapter 4. I feel like it's been taking us so long to get through to the end of this chapter, and we've gone through so much. But this is Lesson 4.9, which is applying the Pythagorean theorem and its converse. So we're going to re-talk about, again, the Pythagorean theorem and what it means to use its converse today. There is a part of this lesson that goes into using the distance formula, but I'm actually not going to be worrying about that, as that's more of an 8th grade standard than a 7th grade standard. And so we're just going to focus on continuing practicing with our Pythagorean theorem and what's its converse. This is actually pretty short of a lesson today, so hopefully we'll have plenty of time to work on stuff here in class. So it says, I can learn to use the Pythagorean theorem and its converse to solve problems. So remember that the Pythagorean theorem talks about right triangles. So I need a triangle that has at least one angle that is a right angle, meaning 90-degree angle. And then I can use a certain equation to solve it out. Remember that that is a squared plus b squared equals c squared. When I solve that out, that means the legs squared plus the legs squared equals the hypotenuse squared. Remember, your hypotenuse then is the longest side of that triangle, which is always going to be opposite of that 90-degree angle. And its converse. They call it this converse is really kind of more so the definition of a Pythagorean theorem. So a lot of the stuff we're going to look at today is going to ask, can you tell if it's a right triangle? Well, remember, right triangles can use the Pythagorean theorem, so we're going to be able to use the Pythagorean theorem to conclude if things are right triangles. And that's what they mean by that converse. Is it a right triangle? It's usually what kind of questions you get for converse. So we're just going to use our knowledge of Pythagorean theorem and right triangles to determine some of these questions today. And I believe there's only 2 examples. So the first one that we're going to do, and it will align with the first 2 problems in your homework assignment, is more of a word type problem. So here in this example, it says that Amy is making a brochure for an HD TV. She says that the screen is 48 inches wide and 20 inches high. Well, those are important details, so I'm going to underline those. What diagonal length should she use in the brochure? So she's using this brochure to explain about this TV, maybe advertising it. She tells me that the screen is 48 inches wide and 20 inches tall. So if you think about this TV screen here, well, my wide here would be how long this is, so that she's saying this is 48 inches. And then the height is 20 inches. They want to know what is the diagonal. So what is this diagonal piece here that I'm doing with dotted lines here? What is this? Well, it should create a right triangle based on understanding how a corner is here. This should be 90 degrees. So we are going to use the Pythagorean theorem to determine then what is this diagonal. So again, a squared plus b squared equals c squared. C squared is my hypotenuse, and that is this diagonal one that we don't know yet. Doesn't matter if I put 20 for A or 48 for A, but let's just put 20. And I'm just going to substitute in. And then since I used 20 for this one, I have to use the other leg, which was 48 squared equals c squared. Now I got to figure out what 20 squared is and 48 squared is. I forgot my calculator, but I can use my phone too. 20 times 20, or 20 squared. I should have known that one off the top of my head, which is 400. 48 squared, though, I don't know if I know that one. 4 times 48. Whew. 2,304 equals c squared. Well, I need to add these up first. So I'm going to add those together, which would give me 2,704 equals c squared. And to undo the square here, we have to use a square root. Square root, close that. And so then I am going to square root this to figure out my solution. So grabbing that calculator, I know for a fact on iPhones, if you're using a phone, and you pull up the calculator app, you have to use it sideways to get it to have all these different types of operations. So if you do try to use that, I'm not sure on an Android though. There is a button then that will have the square root of x, but then there's a little 2 next to the square root, so it kind of looks like this. That means it's square rooting it. So I'm going to click that one, and then I'm going to plug in that 2,704, which looks like I get a pretty even number. That's nice. So C equals 52. So in the brochure, she can say that the the C value or the diagonal should be 52 inches. Okay, and totally fine to use a calculator. I'm not expecting you to know the square root of 2,704. I'm not going to know that either. I'm not going to make you guess. So grab a calculator, solve it up. So we got one more example here to go through, and this is using more so the converse of the Pythagorean theorem, which I had told you that a lot of time those directions will ask, can you determine if this is a right triangle? So tell whether the given side lengths form a right triangle. So we're going to tell, is it a right triangle? Yes or no. So ultimately my answer is going to be yes or no. So let's use these values. We're still going to use the Pythagorean theorem to help us determine, if this is a right triangle. So typically our hypotenuse, or our C value, is going to be the largest value they give me. So I would assume that 25 is going to be my C. Now it doesn't matter if 7's A or 24 is B, but maybe we'll just make this A, this B. So if I'm going to plug this in, I'm going to have 7 squared plus 24 squared equals 25 squared. Remember, with our Pythagorean theorem, we need to square these first, then we can add them. I can't add these together and make it 31 squared. I have to figure out what 7 squared is and 24 squared. Now, I know 7 squared is 49, but 24 squared, I don't remember. 576. And then I got to figure out what 25 squared is. I think that's 625. Yep. Now, really, we've got answers on both sides, but we got to know, does this actually work? Are they going to equal each other? So I'm going to add up these. 49 plus 576. Oh, that does give me 625. Well, 625 does equal 625. Yay, it works. So that means because it works, it is a right triangle. So I'm going to say yes, it is a right triangle. Woo, yes, it's a right triangle. So let's look at B then. Again, the biggest one should be my C. Let's just make 5A and 8B. So we have A squared plus B squared equals C squared. So 5 squared, because all I'm doing is substituting in, plus 8 squared equals 12 squared. And we got to make sure, does that work? I want to make sure it works, so we got to figure out what is all these squares. Well, I know 5 squared is 25. I know 8 squared is 64. And I actually know 12 squared off the top of my head as well. 12 squared is 144. So if I add these together on this side, is that going to give me the same thing as on this side? We're not sure. That's why I'm putting this question mark over that equal sign, because I'm not 100% sure if that works or not. So 25 plus 64. I could actually easily add that one up. So 6 and 2 is 8. 5 and 4 is 9. Does 89 equal 144? No, they're not the same value. So a lot of times if you see that they're not equal, you'll put a slash through it. So no, this doesn't work. No, because it doesn't work, it is not a right triangle. So it could be a different type of triangle, but it's not going to be a right triangle where, you know, you've got 190-degree angle. So it's just not going to work that way. So that's all for this video. We'll continue practicing some of those skills. And since it's our last lesson here, we'll take some time after this to practice and before we get into taking the test next week. So I will see you here in just a little bit to work on the assignment. Let me know if you've got any questions.